All right, hello everyone. Today is the last lesson in chapter 3. It's proportional versus non-proportional relationships. So far in chapter 3, we've looked at proportional relationships, and we're going to dig a little bit deeper and then figure out what non-proportional relationships mean and what they look like. Previous objective was to recognize arithmetic sequences and relate them to linear functions. And today we have two objectives. We are going to write an equation for proportional relationships as well as non-proportional relationships. Make sure you get these objectives down in your notes. And the good news is that there's no vocabulary for this section. All right, key concept, proportional relationships, very similar to the constant of variation, y equals kx. A relationship is proportional if its equation is in the form of y equals kx and passes through the origin of 0, 0. So the example they have here, they gave us a table as well as a chart, as well as a graph, y equals 3x. It goes through the origin of 0, 0. You can see that they went up 3 over 1, up 3 over 1, and continued their graph. It is proportional. The ratio of the value of x to the value of y is constant, similar to that constant of variation, or also known as the slope. So, example number 1, it says the table shows the number of miles driven for each hour of driving. Graph the data. What can you deduce from the pattern about the relationship between the number of hours, h, and the number of miles driven, m? So, what I did is I graphed the table, and there's a linear relationship between the hours of driving and the number of miles driven. So the first part was just to simply graph the data. The second part is to write an equation to describe the relationship. We need the table to figure out what our equation is. So I copied the table and showed you that we have a change in 50 miles over 1 hour. It's a change in y over the change in x. So I get 50 over 1. So my answer is m equals 50h. Also can be written y equals 50x. What we did is we basically found the slope of this relationship. The last part is they want you to use that equation to predict the number of miles driven in 8 hours of driving. So if this was my original equation that we just found in part B, then that's all we do is replace the hours with 8 and solve. So it would take about 400 miles of driving 8 hours. It would take we would drive 400 miles in 8 hours. So with that being said, I want you to take a look at the multiple choice question that you are going to answer in your Google form. We have write an equation to describe the relationship between the hours and miles walked. Then figure out how many miles you could walk in 10 hours. So the first thing that you need to do, you might not necessarily have to graph this, but you need to figure out what the slope is or what the rate of change is between the miles over hours. And then figure out with your equation, if I walked 10 hours, how many miles would that be equivalent to? Save your answer and record it in the Google form at the end. We are on to example 2. Now we haven't talked a lot about non-proportional relationships, so what I want you to write in your notes is that non-proportional relationships never go through the origin of 0, 0. That's what makes them different than proportional relationships. And the y-intercept is always included in the equation, and that will make more sense once we get started. Write an equation in function notation for the graph. So they give us this graph here. And what I did is I already started our table. So I plugged in all my x values of 1, 2, 3, 4, and 5 into the table. And then I plugged in my y values. It looks like at 1, 4, 7, 10, and 13. Your next step is to just figure out what your equation is. So it's the change in y over the change in x, which in this case I'm going up by 3 every time, and my x's are going up by 1. So my equation is y equals 3x. Now what I'm going to do, also known the x for function notation, so f of x equals 3x. Now I'm just going to make a little table here. My x values were at 1, 2, 3, 4, and 5. And right now, the function that I have is 3x. Well, 3 times 1 does not spit out 1. So how do I get 3 times 1 is 3? How do I get back to 1? I need to subtract 2. 3 times 2, if I subtract 2, I get my y values here, which would be 1. So let's try it for the next one. 3 times 2 is 6. If I subtract 2, I am at 4. 3 times 3 is 9. Minus 2 gives me 7. 3 times 4 gives me 12. Minus 2 gives me 10. And 3 times 5 gives me 15. Minus 2 gives me 13. So what I needed to do was find that missing piece to figure out what can my equation be that would make my table true. And it's not just 3x, but it's 3x minus 2. So the function notation for this graph would be 3x minus 2. Now this negative 2 or minus 2 also happens to be your y-intercept. So if they gave you the graph, which this case it doesn't actually quite show you, but it looks like if I went down 1, 2, 3 and over, this graph would continue through the point of negative 2. So that is how you write an equation in function notation for the given graph. So again, we're just going to do a few more examples. Write each equation in function notation for the relation shown in the table. So what I'm going to do is first figure out what is my pattern. It looks like I'm going up by 1 for my x's. And my y's, negative 2 to 2 is plus 4. 2 to 6 is plus 4. So it would be 10, and then 14, and then 18. So my change in y over change in x happens to be 4 over 1. So right now I have this equation, f of x equals 4x. But now I need to test it to make sure, is it just 4x or do I need an ending? So 4 times negative 1 happens to be negative 4. But how do I get to negative 2? I actually need to add 2. 4 times 0 is 0, plus 2 spits out 2. 4 times 1 is 4, plus 2 spits out 6. 4 times 2 is 8, plus 2 spits out 10. So my function notation for the first graph is f of x equals 4x plus 2. Now let's take a look at the second one. Again, it looks like my x values are going up by all positive 1. My y values are going down by 3. So 4 minus 3 is 1. 1 minus 3 is negative 2. And negative 2 minus 3 is negative 5. So that's my table. My change in y over my change in x happens to be negative 3 over 1. So my function so far is f of x equals negative 3x. Now I'm going to plug it back in. Negative 3 times negative 2 gives me a positive 6. But how do I get to 10? I need to add 4. I'm going to try it for the next one. Negative 3 times negative 1 is positive 3. Positive 3 plus 4 spits out 7. Negative 3 times 0 is 0. Plus 4 spits out 4. So this is my function notation for my second graph, my second table, excuse me. So we are already to the open-ended question. I want you to write an equation in function notation for the relation that is graphed. So the fact that I gave you a graph, you might want to start by actually creating a table, which then you will find the slope or the change in y over the change in x, and then test to see whether or not your equation will hold true for your table. We will go over a bunch of examples tomorrow in class. Try to get your open-ended question answered in the Google form, and I will see you tomorrow. Have a good night.